Hey, fifth grade, this is Miss Harvey, and I will be teaching you math for today. So, similar to the video I did last week, I just played the theme song to a popular cartoon. So, your job is to email me the name of that cartoon. This time, the third person to email me the correct name of that cartoon will be the one to receive one extra credit point on their exit ticket today. So you have to be the third person. You won't know whether or not you're the third person. Only I will know that, and I'll email you back and let you know that you earned the extra credit. So, like I was saying before, today we are going to be doing math class together. Math class today is going to be a little bit different, and your teacher should have told you a little bit about this already. So today is the first day where we are going to be talking about new content. That means that math class today is going to be the same as if we were in school. So we left off in math class talking about shapes, and we're going to continue today exactly where we left off. So that's why moving forward, it's going to be really, really important that you watch all videos, because there's no way that you're going to be able to teach yourself new material. And these videos are going to be the way that your teachers are able to teach you new things even when you're not in front of us. So right now you should have opened up a separate tab with your math lesson for today. It is in this week's distance learning files underneath math class. You should have Monday's lesson open. You should have a scratch sheet of paper and a pencil for you to be able to do your work on. Pause the video here and get those materials. Before we start with class today, I'm going to go over the outline for how math class will look moving forward. So the first thing that you will do is the PST, and you will do that independently each day. Then you'll come back to this video in order to watch the discussion. And during the discussion, you'll be engaging in the questions that we ask while checking your answers on your PST. After that, we'll do notes like we do in class, where you'll either write them on a paper in front of you or you'll type them on a document that you're keeping for yourself. Either way, whichever way works best for you, that you'll actually be able to keep up with. After that, you'll do your practice problems by trying them independently first and then continuing to watch the video to check your work. And last, at the end of every math class, you should take your exit ticket quiz that is in Google Classroom. And your exit ticket should only be done after you have completed steps 1 through 4. So if you're ever confused on what you should do in order to have a successful math class, you can go back to the beginning of this video and review those steps. So to start class for today, you're going to start by doing your problem-solving task independently. So again, in front of you, you need to have a piece of paper and a pencil to be writing down your answers. It is not okay to be doing the work in your head. Doing the work in your head is not going to allow you to learn. It's not going to allow you to actually make sure that you're solving all parts of the problem, and it's not going to allow you to check your work. So you should be picking up your pencil now, having your scratch paper ready to go. You're solving the problem-solving task on your own, and then you're going to come back to this video. Pause here and do that now. Hey guys, so you should only be restarting this video if you finished your problem-solving task. And if you did, let's go ahead and chat about it. So for part A, we needed to select what we thought the figures represented. So each figure was drawn and we had answer choices that we needed to pick from in order to determine what it was. Let's go ahead and talk about the first figure. So for this first figure, I started off by drawing some of the things that I noticed about it. So I started thinking about parallel sides. When we last saw each other and were in class together, we talked about a parallelogram. Right now, I want you to say to yourself, what is a parallelogram? So I know if a parallelogram is a trapezoid with two sets of parallel sides. So what I did is I extended the lines for the opposite sides on this figure to determine whether or not they were parallel. And I figured out that this shape had two sets of parallel sides. And because I know it has two sets of parallel sides, then I can determine that it is a parallelogram. I need to select all of the options that apply, so let's keep thinking about these other options though. We've talked about rectangles in class. I want you to go ahead and try and remember, what did we say were the defining attributes of a rectangle? Right, we said a rectangle was a parallelogram with all right angles. So if I go ahead and look at the angles on this figure, I know that they are not right angles. They are not 90 degrees, and they're not represented by the small squares in the corners that show 90-degree angles. In fact, this angle looks to be acute, and I know if it's acute, it is less than 90 degrees. So therefore, this shape does not meet the requirements to be a rectangle. It does not have all right angles. Next, we have two options that we haven't talked much about, a rhombus and a square. We're going to come back to that in a little bit after we talk about figure number 2. So for figure 2, I use the same strategies. I thought about what we have discussed so far and determined whether or not those shapes or those categories fit for this figure. So A says that this is a triangle. I want you to think back to what a triangle is. If you said a triangle has 3 sides, then you're correct. Looking at this figure, it does not have 3 sides, so it can't possibly be a triangle, so we can rule that out. Quadrilateral. What do you remember from class that was the defining attributes of a quadrilateral? Well, I know a quadrilateral is a polygon with 4 sides, so let's count the sides. 1, 2, 3, 4. So based on that defining attribute, this could definitely be a quadrilateral. And again, we're left with those same two choices, rhombus and a square. So now we have to do the job of figuring out exactly what could be the defining attributes of a rhombus and a square in order to help us determine which figure is what. So now I want you to go ahead and take another look at these figures. Based on what you already know about squares, and maybe rhombuses too, what would you classify each figure as and why? Pause the video here and do that now. So what are you guys thinking? Well, figure 1 is going to be classified as a rhombus, and figure 2 is going to be classified as a square. We're going to use these figures to help us understand the defining attributes of a rhombus and a square so we can better understand exactly what they are. So I know that some of the attributes of a rhombus are that it's a parallelogram, meaning it has 2 sets of parallel sides. It's a quadrilateral, meaning that it has 4 sides. But those aren't the defining attributes. Those are just attributes because those don't make it different from any other shape. I want to know what the defining attribute is, and that's the thing that makes it different from other shapes. The defining attributes of a rhombus is a parallelogram with 4 equal sides. Rhombuses do not need to have 4 right angles, but sometimes they can. So if we take a look at this shape, we can't necessarily prove based on just this drawing that the sides are all equal, but I know that a rhombus has to have 4 equal sides, so therefore this figure, because it's a rhombus, has 4 equal sides. If I look at its angles, it does not have 4 right angles, and that's okay because rhombuses don't have to have 4 right angles. They can, but they don't have to. For number 2, it can be classified as a square. What do you already know about squares that helped you determine that? Well, some things that we already know about squares is that they have 4 equal sides. Something that you may also already know about a square is that it has 4 right angles. And those are the defining attributes of a square. Those are the 2 attributes that make squares unique or different from other shapes we've talked about. So the defining attributes of a square is that it's a parallelogram with 4 right angles and 4 equal sides. In my shape, I've drawn and shown that it has 4 right angles, and I know that all squares have 4 equal sides, so this figure must, of course, have 4 equal sides. So we've talked a little bit about that. Now I want us to go on to part B and C and really try and explain that in clear math terms. So pause this video and say out loud to yourself, for parts B and part C, what are the defining attributes of a rhombus and of a square? Okay, so let's talk about part B. Part B is asking what are the defining attributes of a rhombus. So like we just discussed, a rhombus is a parallelogram with 4 equal sides. It doesn't need to have 4 right angles, but it definitely can have 4 right angles. For part C, what are the defining attributes of a square? A square is a parallelogram with 4 right angles and 4 equal sides. These 2 figures sound pretty similar, but they do have a distinct difference. What do you think is the difference between a rhombus and a square? If you said the difference is that a square needs to have 4 right angles and 4 equal sides, while a rhombus has 4 equal sides but does not need to have 4 right angles, then you are correct. Now we're going to think about part D and part E. We want to think back to our hierarchy that we were filling out, and we want to figure out where to place a square and a rhombus on that hierarchy. So, right now, I'm going to scroll down to a hierarchy that I have in my document. What I have showing on the screen is what we already have filled in as a class. And I want you to take a look at this hierarchy and think, where would you place a square and a rhombus? What category would you make it a subcategory of? Pause the video here and think about that. Okay, let's take a closer look at this. Based on our PST, we talked about the defining attributes of a square and a rhombus. Let's start with a square. We said that a square is a parallelogram with 4 right angles and 4 equal sides. So I know automatically that because it's a parallelogram, then of course it belongs to this larger subcategory of quadrilaterals. It's also a trapezoid because it has at least one set of parallel sides, And we know it's a parallelogram because it has two sets of parallel sides. A rectangle, we said, was a parallelogram with all right angles. So let's think to ourselves. Could a square be a subcategory of a rectangle? Does it fit the defining attributes of a rectangle? Is it a parallelogram with all right angles? The answer is yes. A square would be a subcategory of a rectangle because a square is a parallelogram and it does have four right angles. The thing that makes it a little bit different is that it has four equal sides. So I would make a square the subcategory of rectangle. How are a square and a rectangle different? If you said it's because a square has four equal sides while a rectangle does not, then you're correct. Both a square and a rectangle are parallelograms with four right angles, but a rectangle does not have four equal sides and a square does. Now let's think about where rhombus should go on our hierarchy. Well, we know that a rhombus is a parallelogram, so we can start there. A rhombus is a parallelogram. It has four equal sides, but it does not have and does not need to have four right angles. Underneath parallelogram, I have two subcategories, rectangle and parallelogram with not all right angles. Where do you think a rhombus would fit? If you said that a rhombus would fit under the subcategory parallelogram with not all right angles, then you are correct. A rectangle needs to have four right angles, while a rhombus does not. So a rhombus would not be a subcategory of a rectangle. A rhombus would be a subcategory of a parallelogram with not all right angles, because a rhombus is a parallelogram with four equal sides, but it does not need to have four right angles. Going back to the PST, let's go over those answers for part D and E again. A square would be a subcategory of a rectangle because it is a parallelogram with all right angles. The attribute that makes it different from a rectangle is that it has four equal sides. A rhombus would be a subcategory of parallelogram with not all right angles because a rhombus is a parallelogram with four equal sides, but it does not need to have all right angles. Now that we've finished our PST, we're going to go ahead and take some notes together. I would advise that you use a notebook or a separate collection of papers in order to form a notebook that you will use until we get back to school. This way, you'll be able to use those notes every day in math class, and when we go back to school, you'll be able to add those notes directly into your math notebooks. If you have your math notebook from school with you, go ahead and open up to the next blank page. Or you can open up to the shape dictionary that you and your classmates were making together. So today, on Monday, April 6th, we did lesson 18. We learned that we can classify rectangles versus non-equilateral rectangles, and that we can classify rhombuses. So, a square is a parallelogram with four right angles and four equal sides. All squares are both rhombi and rectangles. Then I drew myself a picture of a square as a reference. A rhombus is a parallelogram with 4 equal sides. Rhombi do not need to have 4 right angles, but they can. As you're writing your notes, pause the video so that you can make sure that you're able to finish them. Okay, so you're continuing this video if you already finished writing your notes. The next step for our math class is for you to try practice problems. So you should scroll down and try the practice problems independently, and then come back to this video when you have finished them so that you can check your work. So we're going to start practice problems together, guys. So you should have already worked through all the practice problems, and right now is a chance to apply what we learned in our discussion in order to make sure that we really understand it for our exit ticket and for lessons moving on. So you should keep open your notes so that you can use them, and you should open up the shape hierarchy that is in this distance learning folder to help you be able to explain your answers. So for number 1, it says a square has a side length of 9 1/4 inches. What is the area of the square? So somebody go ahead and remind me, what are the defining attributes of a square? If you said that a square is a parallelogram with 4 equal sides and all right angles, then you're correct. And that's exactly what helps us solve this. So I know that a square has 4 equal sides, and that means the length is the same as the width. So my width is also 9 1/4 inches. Area equals length times width, and so I'm doing 9 1/4 inches times 9 1/4 inches. To multiply mixed numbers, I know I should use an area model. And below you see my work for my area model. Whoops, zoomed in a little too fast there. Let's try again. So I used an area model showing all of my partial products. 9 times 9 is 81. 9 times 1/4 is 9/4, equal to 2 1/4. 9 times 1/4 got me again 2 1/4. And 1/4 times 1/4 got me 1/16. When I tried to add up all my partial products, I realized that I need common denominators. So for 2 1/4, I made an equivalent fraction, 2 4/6. 81 plus my whole numbers 2 and 2 got me 85. Then I added in all my fractions, 85 plus 4/16 plus another 4/16 plus 1/16 got me 85 9/16. Moving on to number 2. We want to circle all the attributes that apply to a square. Here is where your shape hierarchy is really going to come in handy. Make sure you have your math notebook open to your shape hierarchy, or you have a separate tab open with the shape hierarchy so that you can use it to explain your thinking. So, what were you guys thinking? Which answer choices did you say apply to a square? A helpful strategy that I've found is by starting at the top of my hierarchy in the largest category that a square fits into and working my way down. So the largest category that a square fits into is a polygon. And the defining attributes of a polygon was a 2D shape that is closed and has all straight sides. I know a square has to be a polygon because it's a subcategory of a polygon. So therefore, a square is a closed shape and it is 2D. And I can automatically rule out it being 3D because that would make it a non-polygon. Let's continue to use our shape hierarchy to help us figure out the rest. A square is a subcategory of a parallelogram. A parallelogram has two sets of parallel sides, so a square automatically shares the same defining attribute or attribute as a parallelogram. So it does have two sets of parallel sides. 4 right angles. A square is a subcategory of a rectangle, and a rectangle has all right angles. So therefore, a square also has 4 right angles. Equilateral sides. This word may be new to you. If it is, you should copy it down and write a quick definition for yourself. Equilateral just means equal. So, do squares have all equal sides? Absolutely. That's one of the defining attributes we talked about today. So I can go ahead and circle F also. Pausing here, the secret code for today's math exit ticket is kitten. Again, the secret code for today's math exit ticket is kitten. 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 Let's keep moving. Number 3. What is the defining attribute that separates a rectangle from a square? What did you guys say? I think that we should use these figures in order to demonstrate what we know about them to help us understand this. So here I can see that this rectangle has two sets of parallel sides, and so does the square. So that makes them both parallelograms. So that can't be the thing that separates them or makes them different. I also noticed that this rectangle has all right angles, but so does this square. So that also cannot be the thing that separates them. What did you guys notice is the thing that makes a rectangle different from a square? If you notice that a square has 4 equal sides and a rectangle does not have 4 equal sides, then you're correct. The defining attribute that makes a square different from a rectangle is that a square has to have 4 equal sides. Number 4, true or false? Here, it's really important that, again, you're using your shape hierarchies and your shape dictionaries to push yourselves to use really specific language when you're explaining. Number 1, all rectangles are squares. True or false? What did you say and why? This statement is false. And we can use our work from number 3 to help prove that. Why do you think I would use number 3 to help us prove that all rectangles are not squares? Well, I can use number 3 to help us prove that because rectangles do not have all equal sides, but squares must have all equal sides. So that means that all rectangles are not squares. That statement is false. Number 2, all squares are rectangles. What do you think? Well, first, let's talk about the defining attributes for both. What's the defining attribute for a rectangle again? Exactly, a parallelogram with all right angles. And the defining attributes for a square is a parallelogram with four equal sides and all right angles. So are all squares rectangles? In order to be a rectangle, you need to be a parallelogram with four or all right angles. A square definitely is that. A square is a parallelogram and it has all right angles. So all squares are also rectangles. I can prove that with my shape hierarchy because a square is a subcategory of a rectangle. So I know that all squares are also rectangles. Last true and false statement. All squares have four right angles and four equal sides. This last statement is true according to the defining attributes we talked about today for a square. A square is a parallelogram with four right angles and four equal sides. Let's go over the last practice problem for today. If a gigantic ice cube had a side length of 6 centimeters, what is the volume of the ice cube in milliliters? Here, it's helpful to recognize that a cube has all equal sides. It is also helpful to recognize that cubic centimeters are equal to milliliters. So, I won't need to do any conversions. I just need to use my information to find the volume. Because cubes have all equal sides, my length is 6 centimeters, my width is 6 centimeters, and my height is 6 centimeters. My formula for volume is length times width times height. So, when I plug in those numbers, 6 times 6 times 6, I get 216 milliliters. Okay, guys, it was really fun to have our first official math class with new content since we've been out of school. Now, after finishing up your practice problems, your job is to do your exit ticket quiz on Google Classroom. Remember that for your exit ticket quiz, it should be your best work. Make sure you're using your notes and your shape hierarchy in order to help you do your best. Once you finish your exit ticket quiz and you get your score, if you're feeling a little bit confused on our content from today, it's super important that you reach out to your teacher as soon as possible because tomorrow we will be doing a completely different math lesson, meaning that if you don't get help today, you could fall behind very quickly. So if you're feeling confused, make sure to reach out to your teachers today so that they can conference with you as soon as possible to help you understand. See you tomorrow in math class.